Hvala Miloš. Nažalost, ne govorim dobro srpski, so I will do all of us a favor and do this in English. Wow, it's good to be on the stage again. It's a long time. First of all, thank you very much to RSNOG for inviting me, Sloba, Miloš, Velko for convincing me to come over to Belgrade. And today I'm going to be talking about the death of the peering coordinator, and that sounds rather ominous, but there might be a job opportunity in there for you. You never know. So let me start off this presentation with a question. And the question is, part of your job is negotiating with a computer. How does that make you feel? And the realization that you are actually negotiating with computers is something that put me off a little bit. And this is where we're ending up with peering right now. Because if you want to do a peering request with a large-scale network like Facebook or Google, you fill in your details on their portal, and the magic portal decides whether you are worthy or not, and where you can connect or not. And unless you're a really large network, there's no real way of dealing with that. So the disappearing craft of the peering coordinator, what is it you're doing? I'm assuming most of you have heard the joke about the plumber who sends a $1,000 invoice for hitting a pipe with a hammer. And the comeback of the plumber is, of course, it's not about the hammer, it's knowing where to hit. What's happened in peering? There's a large-scale consolidation. There's companies being bought on the access side. There's companies being bought on the content side all the time. So the number of networks that you're actually dealing with is decreasing. Most of the openings for the job of peering coordinator are either at new companies or actually don't even exist as peering coordinator, but you are a strategic negotiator for partnerships. And the number of people being in this business actually hasn't grown all that much. It's I've been in the peering side of the business for the best part of 2 decades now, and I still see the same faces, lovely faces, but it's still the same faces. And traffic, of course, has exploded in that time, and interconnection decisions, which used to be like, hey, we're both on this exchange, let's go set up a peering session, is actually turning into a conversation of, hey, we have a terabit of content for your end users. Kindly just give us space and power in your data center so we can put our cache in. To wit, Google abandoned the position of peering coordinator about 5 years ago. There's no peering coordinators left there. What's on the interconnection side? Well, the tragedy of least cost. We've all been focused on volume, because it is the one thing that we've been inundated with is we have so much YouTube traffic, we have so much Facebook, we have so much Netflix, so it's been a volume play, and only really the very largest access networks, like the scale of Deutsche Telekom, can actually go and say to Netflix, well, that's all very nice, but if you want to deliver your content on my network, here's the price tag for that, and actually have a conversation around that. Then if you look at your upstream provider, your transit providers, if you've actually ever bothered to read the SLA of your transit provider, first of all, if there's anything in there, it covers like availability and congestion. And if there's any performance numbers in there, they're somewhat less than ridiculous. A guarantee that traffic within Europe will be handled within 200 millisecond round trip time, which that's nice. That's probably what I would want to put in the SLA if I was selling transit. And most of it is still solving for traffic volume and much less for performance. And here's why this matters. The performance bit is real time is here. And if there's anything that COVID did for us is kicking real time forward hard. Because all of a sudden, all of us were sitting at home watching an online conference or doing online meetings with your colleagues. And there is a difference here because traffic volumes, which is what everyone was worried about at the beginning of the pandemic, like, does my network scale to having so many people sit at home and consuming content, is actually turning around. And because online collaboration, your Zoom meetings, your Slack, your Discord, your Microsoft Teams, your everything is not about traffic volume. And there's no caching that you can do to sort of save your ass when it comes to getting better quality to your network. And the other thing is, an interesting problem is that all of your consumers on your edge networks are actually now producers. And all of a sudden, this tiny amount of upstream on your DSL connection is suddenly important, because if you want to be able to do a meeting from your home and you have like 0.5 megabit of upstream, then you have to tell your kids not to watch any YouTube while you're doing a conference call, because otherwise your conference call is going to fall over. And this is not uniquely a problem in lower bandwidth countries. This is actually in all the meetings I've had over the last year and a half, most of the people who had problems with this are actually living in the United States. Traffic at the same time is moving to different protocols. So back in the olden days where you could just look at your traffic and do like simple analysis of a TCP session, or look at what's the URL that people are getting, it was all unencrypted, and I'm going to call it observable. But now, a lot of it isn't anymore. The DNS over HTTPS means that you can no longer look at what kind of DNS requests people are doing. So a lot of the traffic that is coming from end users is moving to low latency and encrypted protocols. If there's packet loss in a quick connection somewhere along the way, with TCP you could figure this out. With quick, if there's actually an ongoing debate in the IETF whether to put some unencrypted bits into a quick packet so you can actually start seeing again as a provider, as an intermediate, if something is going wrong. And where round trip time latency wasn't actually all that super important, if you're looking at Zoom or Teams or any real-time thing that you're doing, a 50 millisecond round trip criteria to whatever server platform you're using is now commonplace. And with online gaming now moving into directions like Google Stadia, sub 20 milliseconds is actually on its way. So we're moving to an internet of services. And so you're no longer looking at, hey, Netflix is a fantastic example. I have a lot of people who want to consume Netflix, so I'm just going to go deal with Netflix directly and have them connect to my network. Because Zoom, for example, you know where Zoom is? Zoom sits in cloud, sits in Oracle Cloud, sits in AWS. So how do you get better Zoom performance for your end users? Do you even know what kind of performance you're getting, your end users are getting for Zoom? And actually making this worse, if you're looking at the first hop of where the traffic is going, this is the serverless part. If you have Cloudflare workers, for example, then any traffic that goes from your end user goes to the first Cloudflare pop that your network knows about. But the reality of workers is that there's only very limited intelligence and interaction that actually sits on that pop, because really what that pop does and what serverless does is sort of isolate stuff that you don't want people to run inside of their browsers from a security perspective. It's like database connection and so on. But move that to a more controlled environment like the Cloudflare workers. But the reality is, in order for content to arrive at your end user, it's not that first bit that's really, which is really fast, by the way. Any country that has like a Cloudflare pop, that's something like 5-10 milliseconds, super fast. But then you end up at the problem that that serverless worker still needs to talk to a backend to get something in front of your end users. And a shocking amount of application backends, which is, I mean, you can tell when there's a very occasional outage. A shocking amount of that actually lives in AWS US East 1, the granddaddy of all clouds, in Ashburn in the US. So it doesn't matter if your Cloudflare worker here is really fast and responsive, because it still needs to cross the Atlantic to get you data. And your Cloudflare pop here might not even have the best connectivity to that remote destination where that backend traffic lives. And finally, and I was trying not to touch the subject because people are talking about it way too much, is how you're going to have like edge data centers and 5G and IoT, I mean, all the buzzwords, which means that all of a sudden you're also no longer talking about, if I'm interconnecting to a network, I'm going to do this in this city, in this location. It is on an edge scale, you are talking about a completely different proposition. I have a strategic agreement with another network to connect our networks together in all 973 edge locations on this continent. And that becomes a completely different proposition, because how do you manage, how do you control that? How do you scale that? Which leads me to the following questions about how much you actually know about your network. Of course, you have your network monitoring, you've got your flow analysis, you've got interface statistics, you know something about top talkers. There's probably one or two more things that you know about your network if you're really good. But let's go to the other side. So how much do you actually know about the destination networks, the traffic, where the traffic goes to or comes from? Oh, you typically know from your BGP config where you're sending traffic that's destined for that network. Also, if you're doing flow analysis, you can also tell where you're receiving that traffic from. But beyond that, there's not a whole lot you know. If there is a massive congestion issue 2 hops down, the only way you find out, and I've had firsthand experience with this, is when your customers start calling. One of the this is, I mean, from an example from like 10 years ago, is I was running a network and I had a affordable upstream provider. I'm not going to name any names. And I got a complaint from one of my customers that their offices in Poland were almost unreachable from my network and from the servers that my customer had inside of my network. And it turns out that my very affordable upstream provider was actually being preferred by a very large German incumbent, still not naming any names, as the path towards my network. And and the links between my transit provider and that German network were congested about, I'm going to say 22 hours a day. So there was a massive congestion issue that I couldn't see anywhere unless I started specifically looking at where is the endpoint, what am I looking at? And in order to fix it, I had to do several things that were highly illegal, and if Ivan Popelniak was in the room, he would probably start shouting at me if I told him what I did. But that's how you fix these things. And really, where this is going is you're moving away from like a simple hammer, put a hammer on this pipe and fix things, to defining goals for your network. And you're moving away from just looking at volumes of traffic. I have a terabit of traffic. I have 2 terabits of traffic. I need to get that out. Of course, you need to get the work done. But there's a far more important part of your traffic, which is the high value traffic. Because having great Netflix is nice, but if Microsoft Teams breaks, you have a problem. And this is something that schools found out when they were homeschooling. They were all using Teams, and it was all a horrible mess. If Roblox stops working, at least I know the kids at my home are going to freak out, which they did a couple of weeks ago. But they're going to go on social media and complain about it loudly. If your enterprise customers are having problems reaching Oracle on their brand new Oracle Cloud instances, they're going to walk away because I have 10 minutes, thank you. It's going to be slow, and then they're just going to find someone else who provides a better service. But so it comes down to moving away from just the technical aspects and doing individual connections to what does the business want the network to deliver. And this is a different level conversation. And you can still keep that somewhat technical, because you can say, well, I want direct adjacency, so I want direct connections to my network for 80% of my traffic, which is easy because, I mean, in terms of volume, it's still cat videos from YouTube and Netflix and that sort of thing. And 80% of the applications that the people use, which is Roblox, which is in the cloud, which is Zoom, which is in the cloud, which is Teams, which is in the cloud. So, and it could be any cloud provider in any cloud region. And it could shift around without you knowing. So I want to have the top 10 of the cloud or infrastructure as a service providers. I want to be able to reach those in under 50 milliseconds. If you look at people playing online games, for example, if you're hosting an online game, you're typically not doing that on AWS. You're doing like a small game server because it's way too expensive. So you go to OVH in France because they're cheap, or you go to Hetzner in Germany because they're cheap. But there's a large volume of traffic, which is very latency sensitive, that is all of a sudden coming out of your access networks and going to those places. And one of the other things, of course, is packet loss. And it's no longer packet loss inside of your network, it's the end-to-end that you need to worry about, which needs to be under like at 1/10%, because packet loss, certainly in a connection-oriented protocol, just breaks things horribly. So how do you get there? I mean, this is a pretty basic picture, but there's one box in there that is, I hope is measure, because the only way you can build your network and scale it out and evolve it from where it is right now is measure, measure, and measure again. And then you make a change, and then you want to see the impact of that change. So you measure again, and then you decide, was this better or not? And then you either accept your change or you revert it and you try something else. And Unsurprisingly, this looks very much like a machine learning pipeline, because this is where, if you have enough measurement data, you can start telling your network, these are the criteria you need to meet. This is the physical setup. Good luck. So what are I call it the trifecta of performance. There's the three major components. It's latency and jitter, which is round trip time variance, black holes, so traffic not arriving, path data, knowing about BGP, knowing about trace routes is important. And thirdly, and this is new territory for people doing interconnection, DNS is hugely important. Not having an accessible root server or an accessible TLD server, but what happens beyond that. DNS, time to first answer, is important, because that sort of sets the latency of how long does it take for my end user to start seeing something. Black holes, again, Anycast gets you in trouble. I mean, it's good for if it works, it's fantastic for global distribution. If one of your nodes doesn't work but is still online, it gets ugly. Recursive servers. What servers are your end users using? Since I'm short on time, I'm just going to go through this quickly. So measuring latency, and just for preparing this presentation, get a better view of the Southeastern Europe region, I had a look at the data I could find with my new company. So we have a new measurement methodology that I can apply and just go and paste on end user networks. And so for the last 2 weeks, I did a bunch of tests. I got 1.8 million measurements from around 120,000 different points of view, which are end users. That could be like mobiles, that could be smart TVs, that could be fixed line, that could be mobile. The whole gamut. For Serbia, I had about 12,000 different points of view on around 50 different networks, which is, I guess, most of the access networks in the country. And if you look at the traffic statistics, this is done in percentiles of round trip. And this is not normally something you look at. I'm going to point out the two ones that stick out to the top most. Those are mobile operators, and a 4G network in its own, by definition, the way it's built, has higher latency on the access side, so no surprises there. From left to right, for each of the providers here, you can see the 25th, 50th, 75th, and 90th percentile of round trip towards a set of endpoints. And you see there's sort of this universal sort of ladder, or staircase that you, and the interesting thing is that if you're measuring your AWS performance, because you have a direct interconnection with AWS, and you measure that from your network to the end network, you're going to end up in the 25th percentile. And you're going to look at this and say, that's 30 milliseconds. That's awesome. We're done. However, your end users, in the average case, get 45. The worst 25% gets 55, which is sort of edgy for real time. And the worst 10% of your network gets 70 or 80. And that's Lego video, blocky, slow things, and voices breaking up. What are the best cloud providers? Sadly, on the screen, my lovely visage is overlapping the slide a little bit. But here's the winners in terms of which clouds are actually the fastest from Serbia. And the winners are Google in Frankfurt, then Azure in Frankfurt, then Azure in Zurich, then followed by Google in Zurich, then followed by AWS in Frankfurt again, which, as it turns out, is the most used one. Then AWS in Milano, which is, from a geographical perspective, the closest. And then you end up in France, in Poland, in the Netherlands, and Belgium. And I flew in from the Netherlands yesterday. That is quite a ways away from here. And here's what that looks like on a timeline. This is a 2-week timeline of the percentiles. And what you see in the top line, which is the 90th percentile, you see this day and night pattern, this diurnal pattern. And what that means is congestion, because if the worst part of your traffic performance is decreasing, that means there's congestion somewhere. You don't know where it is because it doesn't show up on your own network interfaces, because it's not inside your network. It is still something that your end users are dealing with. And optimizing your connectivity is actually going to take this away. One of the other things I found while going through the data this weekend is that apparently someone here in Serbia is making weekly backups to AWS in Frankfurt every Tuesday at 3 a.m. I have no idea. But apparently someone turned up a new interconnect with AWS, so that's improved. Path data. Here's a measurement that we did for a customer. One of their customers started leaking a path towards the internet, which is super low volume, so you wouldn't have found it normally. But because we have the intent rules that say this network should not be behind this network ever, we can go and look at all the BGP data around the world and say, oh, hang on, this is weird. And we found something that would have normally taken days of debugging to figure out. Finally, measuring DNS. I'm going to start with a picture of the DNS cloud from Jeff Houston's presentation at Drive 83 last week, because it is just splendid in its misery on describing what happens when you're doing a DNS request. Because you are using a resolver that then goes to another resolver potentially, and that goes to an authoritative that refers you to another. And the worst thing is that your end users are no longer just using your DNS resolvers. They're also using Cloudflare. They're using Quad 8 from Google if they're using an Android device. And why is this important? Because the DNS has become the new service directory. And what you are getting as a reply from the DNS actually varies very much based on which DNS resolver you're using. Quad 8 gives you a different result than your own provider. The success rate of a well-configured DNS setup, shockingly, is only around 98%. And if the DNS gives you an answer that points your end users at not the Netflix cluster that sits in your data center, but one that sits in Frankfurt, then any optimization effort on your side is wasted. DNS caching is a double-edged sword. It's great if you get it right, and it's horrible if something goes wrong, like what we saw with Facebook. And if you have an external DNS provider, then end users that use it are actually painful to optimize your network delivery for, because, and even on the CDN side, because they get a request from Quad 8 for some content. How do they know what the right endpoint is? So, summing this all up, interconnection is no longer just about volume and next hop, and applications are moving to cloud settings, and that requires a completely different approach at how you build your networks, how you interconnect your networks, and how you observe and optimize that stuff. And that is at a completely different level of complexity than what we've seen until now. And automation of this is really the only scalable way forward. And the measurements that you currently have, your own network interfaces, are not telling the whole story. And you need high fidelity, large scale network measurements to automate this. And with that, I'd like to thank you all for your time.
Thank you. We have a question.
You have a question?
Yes.
Yes.
Yeah, we have a question. Even though we went through our schedule, but no problemo. How do you achieve fast failover in Asteroid? Do you use LACP, and how that affects latency? Is subspace connected already?
So that's a bunch of questions.
Yeah.
Asteroid doesn't do failover because IXs, in our deeply held belief, are not a resilient part of the internet. Resilience is something that providers need to solve for, and an IX is just a part of that chain. So if you want resilience in internet exchanges, you connect the two. Is Subspace already connected to Asteroid? Not as far as I know.
So that's it.
All right.
Yep.
Okay.
Thank you very much.
With that, thank you.